Alright guys, lesson 8. We're going to talk about theorems about lines and angles. And I think sometimes it's hard to see the cursor, so I made this really big one now. So, analytic geometry warm-up. Go ahead and, define each of the following. Or if you don't think you can write a definition, write what you would tell a 5th grader, or a 5th grade brother, sister, or cousin if they needed to know the meaning of these terms in order to do their homework. So, pause the video, give these a thought. This one might be new to some of you. These should be very relevant for you. I'm going to burp, excuse me. I feel better now. So, parallel lines, here's an example. Oh, where'd my cursor go? So, parallel lines in the same plane that never intersect. Y'all know that. Can you find examples in our classroom? Think about it. That's right. We got tiles, relatively speaking, of course. We have the borders of the whiteboard, borders of the screen, ceiling tiles, maybe I might argue the brick mortar. So, pretty good examples. Let's look at the next one. Perpendicular lines. So, perpendicular lines are lines in the same plane that intersect at right angles. Y'all know that. Can you find examples? Again, I would go back to the brick mortar. That's about 90 degrees. Same thing with the ceiling tiles. Where they intersect, of course. And the floor tiles. And maybe even in the window frames. Yeah, I see you looking around. That's right. And skewed lines. Lines that are not in the same plane and do not intersect. Can you find examples in our classroom? So this one's a little tougher, but I would argue maybe ceiling tiles and floor tiles, not in the same plane, they do not intersect, would be skewed lines. Okay? So, again, here's our standard, proving theorems and lines and angles. Understand the theorems involving lines and angles. So, corresponding angles postulate. Parallel lines, where's my cursor? So, corresponding angles postulate. If parallel lines are cut by transversal, remember I was talking about this earlier, then corresponding angles are congruent. So, which angles would be corresponding? Corresponding angles are in the same position in the other intersection. So as you can see, we have one. Oh, let me get my cursor. I hope this cursor helps out. 1 and 5. Notice they're in the same position. Okay, in fact, never mind. Let's just go back. So, what's some other ones? Good. 2 and 6. 3 and 7. 4 and 8. Good job. Again, notice, same position between the two parallel lines. Corresponding. And they are also congruent. Okay, note the congruent symbol. 1's congruent to 5, 2 to 6, 3 to 7, 4 to 8. So, watch what happens if we pick up the blue part and move it over the red part. Isn't that wild? Notice they're all congruent. And notice how 1 corresponds to 5, 2 to 6, 4 and 8, 3 and 7. And don't even get me started on how long it took me to get this thing to work. Well, never mind. Oh, there we go. So, corresponding angles postulate. Parallel lines are cut by transversal, then corresponding angles are congruent. Right? write an if-then statement that would be the converse of this corresponding postulate. The converse of this would be of the corresponding angles postulate is if corresponding angles are congruent, then the lines cut by the transversal are parallel. Meaning, if you didn't know these lines are parallel yet, let's get my cursor. If you didn't know that these lines are parallel yet, but if you took 2 and 6 and said they're congruent, then that means the lines cut by that transversal are parallel. Okay? Just like before when we said where'd it go? How parallel lines are cut by transversal, we get corresponding angles. Well, this is different. It's backwards. If we have corresponding angles, then these lines must be parallel. This statement is also true, but you don't have to remember a new rule. Just remember that the converse is always true. Okay? Let's keep going. So, suppose the measure of 1 is 27 and 5 is 27. What could you conclude about L and M? That's right, they're parallel. We can conclude that L and M, remember this is the parallel symbol right there, because of the converse of the corresponding angles postulate. We stated that angle 1 is 27, angle 5 is 27. They're in corresponding locations. They are congruent. That means L and M are parallel. Do you remember what vertical angles look like? Draw a sketch. And when you're done with that, do you remember what linear pair of angles look like? Draw a sketch. Good. You should have something like this for vertical angles. In linear pair, remember, straight line for linear pairs, which makes them supplementary, which means they add up to 180. Vertical angles are opposite of each other, and they are congruent. So there's a property that says if two angles form a linear pair, then those angles are supplementary. What does that mean? Like I just said, the measure of 1 plus the measure of 2 equal 180. Guys, please, please, please keep this in your memory forever and ever. Supplementary means they add up to 180. So earlier we proved the vertical angles theorem. Do you remember what it says? Vertical angle theorem. If two angles form a pair of vertical angles, then they have the same measure. And we talked about that. So here, something cool. If I give you the measure of one of these angles, and in this case I'm giving you the 40, you can figure out the measure of the other 7 using what we know about vertical angles and linear pairs and corresponding angles. Give it a try. So, go ahead, take this time, pause the video, and try to fill out the rest of these blanks. The 2, the 3, the 4, 5, 6, 7, 8, etc. Okay? Trust me, this is a test question. Alright, we're back. These are what you should have gotten. M2 should have been 140 because it being a linear pair. 4 should have been 40 because of vertical angles. And being that you just told me that 2 was 140, again, vertical angles for the 3 and got 140. Being that all of these correspond to this intersection down here, well then that means 5 should be 40, 6 should be 140, 7 should be 140, and 8 should be 40. Now, being that this is a test question, if we messed up just one of them, could that potentially cause a chain reaction? Yes, yes it could. So be careful. Here's something important to notice. Angle 3 and angle 6 are congruent. So is angle 4 and angle 5. We just proved that these pairs of angles will always be congruent, and they have a special name. They are called, and we've heard this before, alternate interior angles. And the theorem we just proved is called alternate interior angles theorem. And we're solving for all those missing angles. So, but some students have a hard time remembering how to identify alternate interior angles. So here's the trick. I think I said this before when we were talking about angle of elevation. The amazing Z thingy. Notice how we make a Z, and these angles will be congruent. So if you can draw a Z forwards or backwards, and the top and bottom of the Z are parallel, then the crooks of the Z are alternate interior angles. I call this the amazing Z thingy. And you can use it to work lots of geometry problems out. Okay? So let's go over this perpendicular bisector idea. Perpendicular bisector is a line that cuts a segment into two equal parts and intersects a segment at a right angle. So let's keep something straight here. The bisector part gives us this cutting in half idea. The perpendicular part gives us this 90 degrees idea. So together we have an intersection that's also cutting a line in half. Okay? So let's work out this proof. Whoopsie daisy, gave you a sneak peek. Let's talk about a plan. It says, given any point D on the perpendicular bisector of AB, we're going to prove that DA equals DB. So here's the hint. We're going to draw us some dotted lines here. And if you can already tell, we have two triangles. Well, we're going to say that since we have a perpendicular bisector, AC is going to be congruent to CB. We have 90 degrees here, which means we'll also have 90 degrees here. And the fact that this is reflexive property, we can say these two triangles are congruent because of side angle side and side angle side, so that works. And now that the fact that the triangles are congruent, we can say the corresponding parts are congruent. And that's what we're trying to prove. So pretty much, long story short, here's the answer in a nice manner. Again, first is always given. We're going to say AC equals CB, or is congruent. Forgot my squiggly worm. And measure ACD is congruent to BCD because all of definition of perpendicular bisectors. Also remember that CD is congruent to CD because of reflexive property. We just discussed that. Now that we have triangle ACD is congruent to BCD because of SAS, we can now say that DA is congruent to DB because of CPTCC. CPCTC. Oh, let's see. Copy the figure above and answer each of the questions below. Which angle is congruent to angle 6 and give a reason? Which angle is supplementary to 6? Give a reason. And which angles are congruent to angle 4? Give a reason. So pause the video, give it a thought. Alright, we're back. Ah, lend to my answers. Just go ahead and ignore that. Which angle is congruent to 6? 3. I would say angle 3 because of alternate interior angles. Let's see here. Which angle is supplementary to 6? We're going to say 5 because of linear pairs. And which angles are congruent to angle 4? We're going to say angle 1 because of vertical angles. And we're going to say angle, let's see, 4 and 5. I would say angle 5 because of, again, alternate interior angles. And I'm sorry I'm shorthanding this. Let's see if I got something else in the works. Let's see. Pikachu, thank you. Hello to you too. Let's see, we got us a nice little worksheet here. We already did that. Transversal city. Alright, let's see here. Identify, again, just check the handout, the practice key on Google Classroom for these answers. Should be pretty easy. Okay. I'll work these two out real quick. If this is 110, that means, oh boy, where's my marker? That means this is 110 because of corresponding angles. And because of vertical angles, that makes the question mark 110. Alternate interior angles makes this 84. This would be, we would call this consecutive interior angles, and consecutive interior angles add up to 180. Okay, another way to think of it is if this is 100, then this would be 100. This is a linear pair, which means it should be 80s. Adds up to 180. But if you also notice, inside this little corner here, 80 plus 100 adds up to 180. So consecutive interior angles add up to 180. 14, alternate interior angles over here. Alternate interior angles here. This would be alternate exterior angles. So this is 47. This would be corresponding, 53. And 18 would be, let's see, alternate interior again. Pretty stinking easy, guys. Uh-oh. Now we got some letters. Let's not overthink it, guys. Alternate exterior angles. So if this is 90, this should equal 90. So 21 x plus 6 equals 90. Subtract 6. 90 minus 6 would be 84. This is 21x. Divide by 21. I'm thinking it's going to be 4. Yep, we're just solving for x. Skadoosh. These are corresponding, so make them equal each other. 75 equals 11x minus 2. Add 2 to both sides. 77 equals 11x. Divide by 11. X equals 7. So I'm just going to set these up for you to solve because I'm pretty sure I have a practice key for you to check your work with. So this will be alternate interior angles, so make them equal each other. And then solve. Again, alternate interior angles, make them equal each other, and then solve. Alternate exterior angles, they'll be congruent. So again, make them equal each other. Solve. Corresponding, they should be congruent, so make them equal each other. And then solve. As I said before, consecutive interior angles. It says find the measure of the angle indicated in bold. So we're looking for this angle, so keep that in mind. But needless to say, consecutive interior means they add up to 180. So x plus 96 plus x plus 96 should equal 180. Combine like terms, then solve. Don't forget to plug it right back in because we're looking for the angle. Again, same thing for 26, consecutive interior angles. Whoopsie daisy, I'm supposed to be adding. Plus 24x minus 1 equals 180. Ooh, that's so tiny. Again, combine like terms, then solve. These are corresponding, so 6x equals 5x plus 10. Then solve. And don't forget we're looking for 6x, so make sure you get your final answer. And again, consecutive interior angles. X plus 109 plus x plus 89. All of that should equal 180. Alright. Again, proving lines are parallel. So, if we're looking for the question mark, that makes the lines U and V parallel. Corresponding, that should be 130. 66, that should be 66. Let's see, 128, alternate interior angles. And again, consecutive interior, that should be 100. Okay. I think the rest of this is pretty easy. Just have to practice, and I have the answer key online. So, yep. Pikachu says bye-bye. Is that it, Pikachu? Yep. Bye-bye, Pikachu.